Chapter 5: Effects of Electric Current on Substances. We know that metals are good conductors of electricity, and that the reason this is so is that metals have delocalized electrons. These delocalized electrons are freely and randomly moving within the metallic structure in such an open circuit. When the circuit is completed, electrons flow through it and the bulb lights. The battery in the circuit provides the necessary electromotive force, which makes the electrons to flow in one direction and not just randomly through the circuit. And so the conductivity in metals is basically due to the presence of delocalized electrons in their structures. In their molten states, metals and graphite still have the free electrons and therefore will still conduct current. But delocalized electrons is not the only way a substance can conduct electricity. Ionic compounds conduct electricity under two conditions. 1. Conductivity in aqueous state. Sodium chloride is an ionic compound. We know that solid sodium chloride consists of an ordered three-dimensional array of sodium and chloride ions. Solid sodium chloride is not a conductor of electricity. The ions of the ionic lattice are held in place by the strong ionic bonds and therefore are not free to move. But when the sodium chloride is dissolved in water and connected to a circuit, it appears the resulting solution is conducting. A solution of an ionic compound like sodium chloride does indeed conduct electricity. But how do they do it? We have already seen the 3D giant ionic structures of ionic compounds. The strong electrostatic attractions holding the three-dimensional lattice structure in place mean that a lot of energy is required to overcome these attractions. So in this three-dimensional lattice structure, the ions are immobile and cannot move under the influence of an electric field. Sodium chloride, sodium fluoride, and ammonium nitrate are ionic compounds and all dissolve in water. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it dissociates into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipole of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity, and this is possible due to the free-floating ions. Following on the same idea, molten ionic compounds can also conduct electricity. The lattice structure is broken at high temperature so that the ions become free-floating. But unlike metals which conduct electricity and remain unchanged, electrolytes undergo some change when they conduct. A case in point is conductivity of lead-2 bromide. Lead-2 bromide is also an ionic compound. In its solid state, it does not conduct electricity. But when heated to a molten state, it exists as free-floating ions and therefore conducts electricity. But in the process of conducting, some brown vapor appears on the electrode connected to the positive terminal and some gray deposit on the negative one. We say that the lead-2 bromide is being decomposed by the electric current. Let us focus here to learn what is happening. First of all, the two solid conductors immersed into the electrolyte are called electrodes. The electrode connected to the positive terminal of the battery is called the anode, and the one connected to the negative terminal is called the cathode. They are mostly made of graphite because it is unreactive and cheaply available. At the anode, the negatively charged bromide ions get attracted to the positively charged anode and migrate towards it. On reaching the anode, the bromide ions lose electrons to form bromide atoms. The bromide atoms combine to form diatomic molecules of the brown bromine gas. This change is illustrated by this equation. At the cathode, the positively charged lead-2 ions get attracted to the negatively charged cathode and migrate towards it. On reaching the cathode, the lead ions gain electrons to form electrically neutral atoms of lead metal. The metal is deposited as gray beads on the surface of the cathode. This change is again illustrated by the following equation. And so lead-2 bromide is an electrolyte. An electrolyte is a substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by the current. The process of decomposing an electrolyte by passing an electric current through it is called electrolysis.